Hello, in our last lesson, we have done derivatives of trig functions, and in this lesson, we are going to do the derivatives of exponential functions. Exponential functions are often used to model changes that is at the very beginning is slow but grow faster. The applications include compound interest, population growth, and the intensity of an earthquake. Radioactive decay are just a few examples of exponential change. So in this section, we'll study the exponential function y equals e to the exponent x. E is a number that is similar with pi. So it is a constant, and it has no ending, so you couldn't write it as a fraction of p over q. You couldn't write it as an integer divided by integer, no ending for the e and pi. And e is a special irrational number like pi, and e is a limit when n approaches infinity, 1 plus 1 over n to the exponent n. It's called a natural number or Euler's number. We use a rational approximation for e is 2.718, and if you see your calculator, you will find this e button on your calculator. So just like the pi, you just click on e, then the calculator will give you the value of e, so you don't have to memorize this one. And e is a number that limit e to the exponent h minus 1 over h when h approaches 0 equals 1. So this is, you can just use it as a formula. And use this formula, we are able to derive the derivative of e to the exponent x equals e itself, e to the exponent x. So you will see e is a very special number, it's a natural number, and the derivative of e to the exponent x is itself. So here I want to explore a little bit, but you don't have to know any of this proof. I just find that it's good to know why it works, okay? So the e definition is this one, so I will write it as to the exponent n. And if you have known the Pascal triangles, so if we expand this one, the number at front will be 1, then the next one will be the n. So the first one is 1 to the exponent n, so it will be 1, and second one will be n, then I will put the h, because this one we have the h exponent, so we put h here, expand it. So from Pascal triangle, this degree is a coefficient for the second term in the expanding, and times 1 to the exponent n minus 1, then this one will be just exponent 1. Then dot dot dot. We simplify it, you will find that it's 1 plus h, then plus the next term will be h squared, then blah blah. So eh minus 1 divided by h, we sub in, it will be 1 plus h squared minus 1 divided by h. So 1 minus 1 cancel out, h divided by h give you 1. And the others will be just h to the exponent something. We sub in h equals 0, all this one will be 0. So the limit when h approaches 0 will give you 1. So from this definition of e, you are able to find out the limit when e to the exponent h is 1 plus nh, 1 over n, then the first h term is 1 at front, then others h sub in will be 0, so you have 1 left. This is true. So after that, we are going to just derive this one, but you are not required to do the proof of the derivative of e to the exponent x. So we are going to do it. It's just for fun. If you don't want to see the proof, you can fast forward the video, just do the example below, okay? So this one, dx over dx is limit. When h approaches 0, then ex plus h minus ex over h. So the definition of the derivative f prime of x from the limit definition is h approaches 0, then f at x plus h minus f at x over h. So f at x is ex, e to the exponent x. So that's the reason we change the degree here. Then we factor the e to the exponent x, the common factor out. You will have eh minus 1 over h left. Then we know eh minus 1 over h is 1, so we have e to the exponent x times 1. Then it is itself. So the exponential function, if the base is e, then the derivative is itself. And the chain rule, if the exponent is not x but is a function gx, then we are going to do the derivative to e first is itself, then do the derivative to gx is multiply, okay? So this is the chain rule. Now we are going to apply this exponential derivative to find the following derivative for example 1. So this one is e, do it first, then the exponent, do it second. So y prime equals e to the exponent itself. No, don't change. Then we times the, so I will rewrite it again. So equals e x squared minus 2x, then times the derivative to x squared minus 2x is 2x minus 2. Then it's done. The second one is multiplication. U v derivative is u prime v plus u v prime. So y prime equals x cubed is 3x squared. Then copy the v here, then plus x cubed, then times the second one, derivative is just itself. Then the third one is e then g at x. So y prime equals e, nothing change. Then times sine x, derivative is cosine x, then it's done. So you will see just use whatever the chain rule, product rule, power rule, quotient rule, combined with the chain rule and also the new formula for the derivative of e to the exponent x is itself, then we could find the derivative of functions involving base e. And we know that for exponential function, it's not always we have the base e. What if the base is not e but is b? So we could rewrite it as base e. So how to rewrite it? We could think that is b to the exponent x equals another number y, okay? Then we want to change it to the base, change it to the base e, okay? So we want to use base exponent equals the power, then change it to the ln is exponent equals log base to the power. Okay, this is what we want. Base to the power. So this one, we want to write x equals log b to the y. Then we could continue to change the base ln y over ln b. Ln y over ln b, it means ln means it's log base e. Then we continue solve for y, so we are going to have x times ln b equals ln y. Then we rewrite it as a backward, so we want to write it okay. This x, this is a ln e, so y the power equals the base to the exponent. Then we do the derivative to this one. This one, y prime dy by dx equals, we have two things, okay? Ln e, the exponential e to the exponent x won't change. Then do the derivative to the ln b. Just times it. Then we continue to see that this ex ln b, ex ln b, we have it somewhere is the y value is same as y equals y times ln b. And the y at the very beginning, we have it is b to the exponent x. So now you will see, okay, the derivative of b to the exponent x equals bx, the y itself, then times ln b. So this one you can use it as a formula. This is a proof, but you don't have to know how to prove it on your test. You just need to know how to use it, okay? So this one, the derivative of the function f prime of x. So b to the exponent x, we won't change. Then just do the ln to the base 2. That's it. The second one is we have 5 to exponent this one. Then we do the chain rule for this one. So f prime of x equals 5 to exponent. It won't change. It is itself. Then times, don't forget the ln base 5. Then continue to do the second, the derivative for the chain rule for the exponent. So it's 2x minus 2. Then it's done. So this is how you can do it, okay? So this is and on your calculator you will see you have log lg is log base 10. As ln, it means l log base e, okay? And we have the bx, derivative is bx ln b, and you could just remember this one because for ex derivative you can follow the same thing. Change the b to e, then ln b is e, it itself log e to the power e give you exponent 1. So it is e to the exponent x. So it works. So this is two formulas you need to know for today. So one is derivative for not base e is itself times ln b. And if the base is e, natural number, it is itself, okay? And after that, we are going to just use these two formulas to apply to some more complicated function, okay? So this one, we have two terms, adding, subtracting, so we could do each of them separately, and this is e to the exponent, so this is a exponential function because variable is at exponent, and we are going to do from the exponent first. So e, we do the derivative first, then do the chain rule for the cosine, then do the derivative to square root x. So 1, 2, 3 for the first term. The second term, the base is once, then the squared will be the second one, then sine will be the, the sine will be the second one, the squared will be the third one. The reason for that is this one only apply to the expression after sine. So 1, 2, 3. This is 3 steps for each of them. So we are going to do the question A, dy by dx equals the base e, nothing change, is itself. Then we do the cosine. Cosine give us negative sine. Nothing changed to the expression after the trig. Then do the expression after the trig, only square root x. It will be 1 over 2, so square root x is x to the exponent 1 over 2. So bring the degree to the front, then degree minus 1. Then this is first term, then second term. The base is pi, then it itself. Then don't forget ln pi. This is for the first base pi, the exponential function. Then do the sine. Sine derivative is cosine. Expression follow, don't change. Then expression derivative is 2x. Then it's done. You don't have to simplify it. And question B. So we need to find the derivative of this one. So we have u over v. Then we do the quotient rule. U prime v minus uv prime. Then for the u prime, v prime, we need to find the order. So this one exponent, it will be 1 over 4. This one 1 over 4 first. Then two terms, the power, then this one squared, then 10 after. This time is 10 squared, so we do the exponent first, not x squared. If x squared, we do 10 first. And this one is just exponent first, base first, then exponent chain rule. This one is just power. Okay, so now we are going to do the derivative. So dy over dx equals the squared (8 to the exponent 2x minus x to the exponent 9 squared). Then u prime. This is 1 over 2. Then copy whatever the underscore fourth root. Don't change. Then degree minus 1. That is the first one. Then the second one in the bracket, under the radical sign is 6x5. Then plus degree 2 tan degree 1x. Then continue. Solve for the 10. 10 is secant squared x. Bracket. This is just u prime. Then follow the v8 2x minus x9. Then copy the u here. Then continue the v prime. So the v prime is a little bit bracket. So here. So I will write here, no space. So 8, 2x ln 8, then times 2, then minus 9x8. So this is a whole thing here. And you don't have to simplify it, we just double check it. Okay, degree, then whatever in the bracket, then times the denominator we don't change, then minus the u, then do the y derivative. Okay, so this question is a little bit long question. Okay. So this is example 2, then example 3, then example 4. This one, look for the equation of tangent line again. Then we know for equation of tangent line, we need to find mxy. Then sub into y equals mx plus b to find the b value. So this one, we need to find m first. M is dy over dx equals quotient rule, so the denominator squared. Then this derivative is itself, then times the y, then minus u times derivative of the y, 3x squared. Then simplify it. Or we could just sub in the number. So x equals 3, the slope equals e to the exponent 3 times 3 cubed minus e to the exponent 3, then 3 times 3 cubed, all over 3 squared, sorry. Three to the exponent 6. Then these times together, you have 3 is 3 cubed. So you have e to the exponent 3 times 3 cubed minus e to the exponent 3 times 3 cubed is 0. They are same. So it's 0 here. Then we have the slope equals 0. We want to, it means you have a horizontal line. Then we want to find the y value. When x equals 3, sub in to the original equation, we have y equals e to the exponent 3 divided by 3 to the exponent 3. It's e cubed divided by 27. So for the horizontal line, it will be y equals this number, okay? Or you could sub in. So you sub in m equals 0, xy equals 3e cubed over 27 into y equals mx plus b. You will find out y is e cubed over 27 equals 0 times 3 plus b. So b, it is the y value at there. Then we have therefore y equals 0x plus b is e cubed over 27. It is a horizontal line. And if you know it's a horizontal line, then you could just go from here directly to the equation is y equals e cubed over 27. You don't have to show me sub mxy solve for b, because b, it is the y value at that point. So now we have one last question for the application of the exponential function. So Mary has just bought a new motorcycle for $15,000. The value will depreciate. So the equation gave us depreciation is e to the exponent negative t over 5. So it asks you at what rate is the value of motorcycle depreciating. The instant Mary drives it off the dealer's lot, it means when t equals 0, the value will drop. So we want to find the derivative when t equals 0, the rate of change. And B decide that she will stop insurance coverage for collision once motorcycle has depreciated to 1/3. So it asks you if it's 1/3 of this $15,000, then what's the time? And question C, it asks you for the rate again. So subbing this t, find the derivative of the value. Okay, so we want to start question A. When the t equals 0, v prime equals what? So we start from v prime. v prime t equals, the constant will not change, so it's 15,000 and times. This one is e, then chain rule. This is second one, so e to the exponent something won't change. Negative t over 5, then times the derivative to negative t over 5. It's just 1 over 5 negative. And we sub in t equals 0. So v prime 0 equals 15,000 times e to the exponent negative 0 over 5 times negative 1 over 5. So anything exponent 0 is 1, so we only have 15,000 times negative 1 over 5. It will give you negative 3,000. And what this one means is dollars, then the unit is the number of years. So every year at the very beginning it dropped 3,000 already. And the question B, when it will 1/3, 1/3 will be 1/3 times 15,000 equals this expression to solve for t. E to the exponent negative t over 5. So in order to solve for t, we want to isolate t. We don't want to see the 1500 at this side, so we want to move it to other side. It will be the divide 1500. So 1/3 equals e to the exponent negative t over 5. Then in order to solve for the exponent, we want to use a exponent equals log base to power. Okay, so this is the exponent, this is base, this is power. This is base, this is exponent. So we have negative t over 5 equals log base to the power 1/3. And the log base is just ln. On your calculator, you have that button. So solve for t, we move the negative 5 to other side, will be times negative 5. So t equals negative 5. Log E is ln on your calculator. Then get your calculator out, do the calculation. You are going to approximately 5.545. This is in number of years. Okay, so and question C is just, so I will go here. For question C, we just sub in t equals 5.45 to find out v prime at 5.45 equals what? We sub in t here, we have negative 300,000 times e to the exponent negative 5.45 divided by 5. Then get your calculator out. It's around negative 1,000.61 cents per year. So you will see after 5 years, the value of the motorcycle dropped less than the very beginning, the first year, 3,000. So now read the statement. Therefore, the value of the motorcycle is depreciating at 3,000. Because we say depreciating, it means going down. We don't need to write a negative sign per year. When Mary drives off the parking lot. Question B, at 5.45 years, the value is 1/3. Value is 1/3 of the original price. And question C, the value is depreciating at 1,061 cents per year. Okay, so this is for this lesson, and the assignment work is on Delta Math 5.2. So go back. What we have done in this lesson is we have learned the derivative of base e to exponent x is itself, and if the base is not e, it will be itself times ln b. Ln means log base e. And after that, we have used this derivative for exponential functions to find the derivatives for composite functions, and also we have find the equation of a line, find the mxy, then find the b, and also we have did the application of the car depreciation. Okay, so that is all for today's lesson. Thank you.